Hey guys, it's me, Pretentious. Sorry, let me try that again. Hey guys, it's me, Meromorphic, but you can just call me David. If you're familiar with my channel at all, you might have noticed that I changed my channel name from David Mueller, my name, to Meromorphic. There's actually a funny story behind that, but I'll save it for the end of the video, because I kind of just want to get right into this. Today I wanted to talk about some of the physics behind the Clovis Bray Journal lore book that was found in the Beyond Light Collector's Edition. If you weren't aware, I actually have a background in physics, but don't worry, we're not going to get into anything crazy, any kind of maths. This is kind of like some pop physics video, the really cool shit that was in this lore book. Alright, so first up, we're going to be talking about Europa. This is the place that almost all of this lore book is based around, and it's obviously where we're going to be going in this new expansion. So Europa is a moon of Jupiter, one of 79 moons, in fact. And that's just as it stands currently. More could be discovered at any time. 79. Jupiter really needs to keep it in its pants. It's one of the 4 moons that was discovered in the 17th century by the famed troll of the Catholics, Galileo. It's the 6th largest moon in our solar system, just slightly smaller than Luna, Earth's moon. It has a thin oxygen atmosphere, but it's not thick enough to breathe in, even if you didn't immediately turn into a popsicle when you got out in its negative 171 degrees Celsius weather. So Europa is most well known for its thick ice water crust that's 100 kilometers deep, or about 10 Marianas Trenches, or just under 55,000 Post Malones. The reason the moon is able to have liquid water under the surface is because of a crazy cool thing called tidal flexing. This is a complex process that actually stems from the same forces that creates tides here on Earth, hence the name. See, when an object revolves around another object, it doesn't usually do so in a perfect circle. Instead, it's an ellipse, or an oval. So almost all of your middle school science textbook pictures were wrong. Because of that though, gravity works differently at the different points along the revolution. Quick aside, there is a difference between the terms revolution and rotation. Rotation is when something spins like a top. Revolution is when one thing goes around another thing. Stop getting it wrong. This is literally the most important thing in the world to me, and you're all letting me down. Whew. Okay, anywho. Since gravity is a function of mass and distance, that is, the more mass you have and the closer you are to some big object, the more you feel it. This means that here, the closer side of Europa is attracted more to Jupiter than the further side is, so the moon overall gains sort of an oval shape. When it's further away, this oval shape goes back to being more like a sphere. The same sort of thing happens between Earth and the moon, in both directions, creating tides on the Earth and a similar flexing on the moon. However, the moon's orbit around Earth is much closer to circular than Europa's, so this flexing isn't as big. But you can imagine, though, a giant ball of ice the size of the moon that is constantly changing shape is going to start heating up because of the friction that occurs as it squeezes and then goes back. Try squeezing a stress ball over and over really fast and you'll feel this same heating happening. So that's exactly what tidal heating is. Congrats, you just learned a thing. The next interesting thing I want to talk about is in Entry 4, the AI of the Hanu spacecraft discusses the event where Clovis Bray discovered an artifact of the darkness on Europa. He describes an event of a Majorana massive light sterile neutrino. What the hell is that? Let's break it down word by word. A Majorana particle is a fermion that is its own antiparticle. Well, that didn't help very much. What's a fermion? Well, a fermion is a particle that is bound by the Pauli exclusion principle. That is, there can only exist one at any given point in a particular energy state. If you ever took chemistry and learned about electrons and atoms and wondered why each energy level can only house so many electrons, it's because of the Pauli exclusion principle. Each of those states are actually divided up into smaller ones. They just show it to you this way because it's easier to grasp at first. And each level can only actually house 2 electrons. But wait, I just said 1. Yeah, that's because electrons have a thing called spin, and spin up and spin down are technically 2 different states, so spin up in energy state A is actually different than spin down in energy state A. Anyways, so a Majorana particle is a particle that is its own antiparticle, and it follows the Pauli exclusion principle. Well, there's only actually one type of particle that does that, and it's the neutrino. So to call it a Majorana neutrino is kinda, well, redundant. The reason a neutrino is its own antiparticle is because it has no charge. So for example, you have an electron, negative, and its antiparticle, a positron, which is positive. But if a particle's charge is 0, then what's the negative of that? It's still 0. So that was one of the words. What were the rest? A Majorana massive light sterile neutrino. Okay. Well, the rest are pretty easy. A massive. Well, the neutrino has mass. That seems kind of like a duh point, but it's actually kind of interesting. For a long time, physicists thought that it didn't. They realized that the sun should emit a certain number of neutrinos based on how bright it is, its age, etc. But when they measured, which is really hard by the way, because neutrinos don't interact with matter nearly as strongly as other particles, basically just passing through the sun and the earth like your boy walking through a thought shop. I don't even know what that means, but it has resulted in one of the coolest experiments, which is a massive detector underneath the ice in Antarctica called IceCube. So anyways, when they measured the sun, they found that only 1/3 of the number of neutrinos they predicted to find, which has a number of, let's say, unsettling consequences. Was the sun older than they thought? Was it close to going red giant and killing the Earth? Well, probably not either. We were just wrong. Long story short, we eventually found out that neutrinos actually do have mass, and they can mix, which would mean that the old standard model of particle physics, which predicted them to not have mass, is at the very least incomplete. So lastly, we have light and sterile, the last two descriptors here. Light is there just because these particles are tiny and have tiny masses, on the order of 10 to the minus 37 kilograms. For reference, an electron is 10 to the minus 31 kilograms. So a neutrino is 1,000,000 times lighter than an electron. And sterile just means that the neutrino only interacts with matter via gravity, as opposed to electricity, magnetism, the strong and the weak forces. So, we have Majorana massive light sterile neutrino. 3 qualifiers that only apply to neutrinos. So it's a little bit more than redundant. When Clovis and company build the actual Vex gateway, Hanu again gives us a little physics insight on how our Milky robot buddies travel. He says it is a non-gravitating, purely geometric wormhole of the Ellis configuration. What does that mean? Well, an Ellis wormhole is basically just a wormhole that is theoretically traversable. It kind of looks like 2 drainage holes ass to ass. This description is special because an Ellis wormhole has no gravity. It's literally just a hole in space that connects to another hole somewhere else in space. This is opposed to something like, say, a black hole, which has gravity so high that not even light can escape its event horizon. So saying that it's a non-gravitating, purely geometric wormhole is yet again redundant, because that describes an Ellis wormhole. Hanu then says that the portal has no singularity and no firewall. A singularity is when some mass is crushed down by its own gravity, like when a star is old and runs out of hydrogen to burn, so that its fusion reactions can no longer support its gravity. Foreshadowing. And it collapses in on itself into a black hole. Theoretically, at the center of that black hole is a single point, infinitesimally small, smaller than an atom, smaller than, well, anything. The smallest a thing can be. So saying that this Vex gateway doesn't have a singularity is good because, well, when you get one of those, walking into it is not going to be a good time. You'll literally just be pulled apart atom by atom. But what is a firewall? And what is ER equals EPR? So I'm not even going to open that can of worms. It is really weird, and it is a solution to a paradox involving quantum entanglement of particles created by Hawking radiation in black holes. Yeah. But not only that, the whole firewall solution itself is extremely controversial and not even close to being a provable thing yet. So to say that this portal doesn't have a firewall basically would mean that our understanding of quantum entanglement is incomplete. Spooky. Finally, Hanu says that the wormhole connects 2 4-points in our spacetime. This part is easy to explain. Any point in space can be given a coordinate. You all remember the XY axis from your algebra class, and you remember you can make a point that has an X and a Y coordinate. Well, if you make that graph 3D, the 3rd dimension would be called Z. So a point in this space is a 3-point in the XYZ coordinate system. The fourth coordinate here is just time. So a 4-point just specifies a specific point in time somewhere in the universe. This is actually interesting though, because it means when Clovis and company go through the Vex wormhole to a specific 4-point, they may actually be going into the past or present. It's kind of left ambiguous. The last thing I want to talk about is that badass forge star that they find on the other side of the Vex gateway. They call it a Type O Hypergiant. That sounds freaking awesome, but what is a hypergiant star? Well, to put simply, it's a big boy, a big, bright boy. These stars are much, much larger than the sun, basically as big as a star can get. Like Clovis says, this one in particular would gobble up the entire freaking solar system if it replaced the sun. It would go all the way out to the orbit of Neptune. They're also massive. Obviously, if it's that big, it's gotta have more mass, right? Well, they're actually on the order of like 25 times more massive than our sun, and they are bright. Blue hypergiants have a luminosity, which is a measure of brightness, on the order of tens of thousands up to millions of times brighter than the sun. However, due to this size and luminosity, they are extremely unstable, usually only lasting a few million years before going into supernova, like they say in the lore book. One of the coolest pictures you'll ever see is of a hypergiant, Eta Carinae. Eta Carinae. Eta Carinae. I think I'm pronouncing that right, I never took Latin. It's the bright object in the center of this picture, and the stuff around it is the result of a little temper tantrum that the star had just under 200 years ago. So that explains the hypergiant part, but what are they talking about when they call it a forge star? Well, like I said, a hypergiant is inherently unstable. This is because stars use fusion to, let's call it, stay alive. Fusion is whenever two atoms are pushed together. But if you think about it, that means their electrons must be pushed together too, which sort of violates the Pauli exclusion principle. Well, it turns out if you push hard enough, give it enough pressure, and wait long enough, you can actually get these particles to combine. And whenever you combine two hydrogen atoms, you wind up with a helium atom. So there's this constant dance of fusion powering the star and gravity trying to crush it. It starts with hydrogen atoms as their fuel, which combine to create helium. Most stars can use this helium as fuel as well, but it's harder to do and gives less energy. Larger stars can use the byproducts of the helium fusion, and so on and so forth, until the star starts creating iron. The further and further up the periodic table it goes, though, the less energy is produced, and it usually stops at iron or below. Over time, the star will use up all its hydrogen and its helium, and the remaining fusion reactions will no longer be powerful enough to sustain that dance with gravity. Depending on the type of star, this will result in different outcomes, but for a hypergiant, it usually means supernova. And with hypergiants, this happens relatively quickly. Like I said, on the order of a few million years. Compare that to our sun, which is nearly 5 billion years old, and you can see why these stars are called unstable. So what does that all mean though? Well, apparently this star, 2082 Volantis, was determined to be 13 billion years old, nearly as old as the universe itself, which is approximately 13.7 billion years. So what gives? Well, apparently the Vex have been feeding this star hydrogen to keep it fueled and prevent it from going supernova. This has an interesting consequence though. That extra mass won't just go away. It will be fused and turn into heavier elements that will stay within the star. So this star must keep growing and growing in both size and mass. What effects might that have? Would they have to keep adding more and more hydrogen each time they refuel? Because surely that extra mass must be harder to keep from collapsing. The other thing is, why do this at all? Apparently, they are using some sort of mirror system to absorb the radiation, maybe something like an incomplete Dyson sphere. But this doesn't really track because it probably costs just as much energy to add more hydrogen to the star as they would get from the radiation. So, thanks for coming to my TED Talk. I'm glad I could discuss some physics with you guys, and combining it with Destiny was really awesome, because they are two of my favorite things. But anyways, I promised you guys a little story, and it's the reason why I changed my channel name from David Mueller to Meromorphic. By the way, if you're not aware, meromorphic is just a math term that describes a specific type of complex function. It really has no greater meaning for me. Honestly, I just thought it was a cool looking word, so I used it. But anyways, why did I change it? When I created my YouTube account, it was tied to my personal account. and I use my personal Google account for everything. But initially, I didn't want my YouTube account to have my full name on it because I wasn't super comfortable with that at first. So I changed it to DHM Plays. That stands for David Houston Mueller Plays. But anyways, cut to the middle of the pandemic, I placed an order online through Google with Five Guys burgers. So I get in my car, go to the store, put my mask on, and wait inside for my order to be called. A few minutes later, I'm waiting for David Mueller to be called. Instead, I hear a really confused cashier call, DHM Plays? DHM Plays? Yeah, it was a little embarrassing. Hearing somebody else say it made me realize how fucking stupid that name was. So I knew then I either wanted to use my full name and my personal account as my YouTube name, or do something else. And so after using my full name for a while, I decided I wanted to separate my personal Google account with my YouTube account, change them, and then I decided to add a little pretentious name. So now you have it, Meramorphic. Anyways, guys, thanks so much for watching. I appreciate it. And if you're not, get subscribed. I just started a Twitter for this YouTube page. You can go ahead and follow me at Meramorphic8. But yeah, I'll see y'all next time.